Hello, how are you guys? So our chapter two is going to be focused on basically on the evolution of computers or the evolution of digital devices and its components. We have to understand how a computer works or how these digital devices that we have nowadays work, which means that we have to understand the components that compose those devices. But before we do that, before we analyze the digital devices and their components, we have to take a look at the evolution of such devices. How did we get to the point where we are at today? So today we have some very evolved high-tech digital devices, computers, smartphones, tablets, um, wearable devices, so and so on. But how did we get to this point? So the idea in this first video is to look at the evolution of technology itself. It's going to be more of a introductory topic. We're not going to go very deep into into this subject. So we're not going to discuss how the early digital devices arise, how they were built. But we're just going to mention the evolution of such devices to put a timeline and let you understand how these components evolved to what we have nowadays. So this is our first topic, computers, technology, and interface. Just a brief history. So these are the early computers. So we started with, for example, Z1 in 36, ABC computers from 39, and then Mark 1 from 44. So you can see some pictures here of these computers on the left here you have Z1, on the right you have ABC. So you can see from these images that there were no digital devices as we know nowadays, right? So these are basically these are mechanical devices. And then the vacuum tube was invented. So John Fleming was an assistant to Thomas Edison, who continued working in the field of electronics. He worked for a radio that later developed an electronic component that he incorporated to his field where he was working. So he incorporated that into a radio. That's what he knew. His invention used heat to control the flow of electricity, right? Which now is known as the vacuum tube, and that's what it became later that year. This component had a wide range of uses in electronics. So as we can see here, over time the vacuum tube was refined and improved. So we have the light bulbs. We're going to see later on that we even have our TVs that probably most of you guys, such as myself, used, which is the tube TVs. So new capabilities, but before that actually happened, new capabilities were added to improve performance, as was done with the triode. So the bulb in the early stages, they were built using diodes. Then they were evolved to use triodes. And some very popular electronics came up. So as I mentioned, we can see the tube TV over here. Basically, any device that would carry a screen would use the vacuum tubes. and radios as well. In this is going back to 23. Edwin Armstrong created the first portable radio, so that was back in 23. But then we started to evolve based on the vacuum tubes. We continued to evolve to more sophisticated digital devices, and that's when the ENIAC was created in 46, and this is a photo of the ENIAC in 45. So as you can see here, is if you observe, maybe some of you guys haven't seen, but probably have heard that in the early stages of digital devices, machines, computers were huge. They would be enclosed within an entire building, or at least they would fit in an entire room. They were huge. And well, actually, you can see this happening right here. This is just the ENIAC in 45, one single computer. There it is. Then in 53, we had the Whirlwind that's in MIT. Of course, as most of um, the 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 evolution of digital communication and digital devices, they most of the times they start within and in the premises of an academia. They may be funded by government or by enterprise corporation, private corporation, but the studies will always, or not always, but most of the times they will start in the academia. And this is the UNIVAC, Universal Automatic Computer in 51. That's the first commercial uh, computer. And then we had the breakthrough, we could say. So the precursor to personal computers, which was Sputnik. So for those that don't remember, um, Sputnik was the technology that allowed a digital device to land on the moon. It was invented in 47, but it did not play a major role in electronics until later 50s and early 60s. It was a solid state device, no heat, glass, warm up, and use far less power, which means that this is the device that changed how digital devices were created. Because as you can see here, now we're talking about a component that would allow us to create devices, digital devices, in a that could actually become commercial. Because now you can create digital devices that are not going to warm up too fast, at least. They're not going to cause any harm. They're not going to blow up. They're not going to burn very quickly. And obviously, they use far less power, which is also important because, well, if we look at those computers in the early stages that would um, require an entire room to be turned on, imagine how much power, how much electricity it would require. They would require. So then we continued to evolve. You can see here radio that was a lot smaller. This is the Apollo spacecraft computer. So as you can see here now, these digital devices, specifically talking about computers, they reduced, they drastically reduced in their size. And then in 71, we were introduced to integrated circuits, which is what we have nowadays. It's still what we have nowadays. Obviously, they're a lot better. They're much more evolved than what we had, but still, it's what we use nowadays. Um, so you can see here that now we have these circuits, these integrated circuits, that they are a lot smaller than what we had before 71. So for example, here, as you can see, the Intel chip on the right contained 135,000 transistors. That is a lot of capacity, that is a lot of power in such a small device. And this one is a microcontroller, which is also very powerful. I am going to tell you, not now, but in the right class, I'm going to tell you about a microcontroller that I used in order to create and to adapt an embedded system. And basically, all the processing capabilities that I used was done in such device. Actually, smaller than this one, but still a microcontroller. Now we can see here the evolution of computers themselves, not just digital devices, but now going further to the evolution of computers. So you can see here a computer terminal. This is a computer using a Intel 8008 with just one CPU and only 2K bytes of RAM. And this is a text-only computer with 80 characters per 12 lines. Here you have the first Apple in 76, just 1 megahertz of memory, 4K bytes, not bits, 4K bytes of RAM, and also this is the size of the screen with 40 columns by 24 lines. This one right here. Then we started to evolve. In 77, we had the Apple II. Well, actually, if we take a look at the apples, I believe that most of you watched or read about the how Apple evolved in the history of Steve Jobs. So basically, I believe that most of you know the history, know the story involving the company and its creator. So the 77 Apple II shown here with twin floppy disk drives and monitor. The Apple II featured an integrated keyboard, sound, plastic case, and 8 internal expansion slots. So as you can see, it's integrated. And we were able to see that in one of the Steve Jobs movies, where they would create a computer that was integrated, the keyboard and the what we know today as the tower, that in cases all the components, they were integrated. So the components and the keyboard were integrated in one piece. Also the display device. Now, if we think about the interfaces, and basically first we have to understand what an interface is. So the interface are the components or the devices that allow us to interact with that specific device or that specific solution, right? So let's first take a look at some basic interfaces and not related to computers, just to understand the concept of an interface. So some simple interfaces here. We have a single part tool Basically, we just have a rock, we just have a stone, we have multi-part tools, right? So here we're talking about tools, we're not talking about computers. So this is a single part tool. Why? Because it's independent. We just need this rock in order to do whatever we want to do, as long as we can do what we want to achieve with that specific interface. But it is an interface because this is the device or this is the tool that I interact with. Now here I have a multi-part tool. Why? Or a set of tools, because I need these two devices in order to achieve what I want to do. We also have some other types of interfaces. If we look at this mechanical motion um, device here, right, it's a mechanical motion driven device. We also have some powered interfaces. For example, if we take a look at this type of solution here, it's a powered interface. Why powered? Because what I want to do is I want to treat my soil, but in order to do that, I need some power. I need energy, which is driven, which is can be achieved by having that horse pulling the device that I'm using. So it is a powered interface. We have some other examples. Now we start to evolve. We can look at this example here where the water is powering the interface. So in order to get this wheel turning, I need the water to drop on top of it, which is going to put some pressure, put some power on that wheel, and it's going to spin. And we also have start with the evolution of fuel, and then we start seeing some communication interfaces. So several different types of interfaces here: sensory feedback, human intervention. As well, I've seen this in rural areas in Brazil. I don't know if you guys have ever seen it, but this is a telephone, a device with real-time feedback. Basically, this is uh, uh, it can be a radio, it can be also a telephone. In this case here, it's a radio that you can use to communicate in real time. This is the interface. That's the device that you interact with in order to achieve your ultimate goal, which is communicate with someone else or with a bunch of other people. And we also have what we know nowadays as uh, the common telephone, which shows us this is a type of communication interface where we can see the input and the output. Basically, this part of the telephone here, right here, that's where you have the input interface. Why? Because when we speak, the sound goes in here. And when the other person on the other line will speak, that what that person spoke will come out. So I have one single communication device with the input interface and the output interface. Then the electronic interface devices came up. We started with the analog or mechanical devices. We evolved to digital interfaces. Now, I'm sorry, when I'm not talking about the analog or mechanical or digital devices, but analog or mechanical and digital interfaces, right? We now here we have buttons and we have this display, this LCD display. So now we can see that the devices started to become digital. And basically, only after the evolution of the electronic devices, we were able to see what we know today as the internet. Well, actually, the history of internet actually started in 45 with the Memex. Then the hypertext was created, which is basis for the HTTP protocol, which is the standard protocol used in internet, at least to browse, to visit web pages. It's based on the concept of hypertext, and it's been created in 1960, but it didn't make such a success at the time, basically because, well, the digital devices were still evolving. We did not have commercial computers, so the commercial computers actually became uh, the they when they actually became commercial, when computers actually became commercial, that's when all these technologies, other technologies, started to become commercial as well. So the hypertext was created in 1960, but it was only basically it was used in academia and in the military environment. The ARPANET, the Advanced Research Projects Agency, that came in 1969, and this is what was basis for what we know today as the World Wide Web that was created by Tim Berners-Lee in 1990. And basically, what Tim Berners-Lee did was to put together the ARPANET. So the structure of the World Wide Web was based on this network, ARPANET, combined with the hypertext. So he created the HTML, which is the hypertext markup language. So it's a programming language based on hypertext. So basically, what happened here was web pages became viable. So you could use computers to visit web pages that were not only text based but graphic based. So you could have text, images, videos, sound, and also very important what was very important to make the internet so successful, or at least the World Wide Web so successful was the hyperlinks. One link that would take you to another location or another web page. Well, but before the internet became successful or known, the interface was command line based. So you'd interact with the computer only using a command line based interface, as you can see here. Obviously, this would not help people. This is not a friendly interface. If it's not a friendly interface, regular people, are not going to use. They would not use. So that's why basically two operating systems became so important, or at least two companies, Microsoft and Apple. Mostly Microsoft, because Microsoft was able to introduce, at least in a large scale, they were able to introduce a graphical interface that would allow users not to interact with this type of window here, not this type of screen, but with a very, very friendly user interface based on icons, mouse, and a pointer. So you'd use the mouse to control your pointer, and you'd have some icons to help you get where you wanted to get. So then we were introduced to the graphical user interface. It uses computers graphics capabilities to make the program earlier easier to use, frees the user from learning complex command languages. It's based on pointer, icons, and desktop. Relies on Windows, icons, mouse, pointer interface. And this is what we still use nowadays. So in 1984, it began with the Mac Paint. It was a 2-bit, basically two colors, black and white, a 2-bit interface, but you were able to work with text shapes, fill boxes, textures, and type tools, as you can see here. This was a huge game changing, right? So imagine that you were limited to this. Basically, you had to code in a not friendly at all interface. You had to code whatever you wanted to do. So let's say that you wanted to print a document. Well, you did have some document processors, not Word per se, but you had other solutions such as Star Office that would give you a document processor, but still you had this interface and you still had to do some programming in order to, um, let's say that you want to break into another page or you want to highlight a text, stuff like that. You had to use some coding, and now you're facing this type of solution here that basically you have your mouse to control the cursor and click on these icons here that would allow you to do whatever you wanted to do, whether it's picking a pencil or painting an area with that bucket. So it was a huge evolution. And this is another screen of what we had. This is, I believe this is Windows 3.1. I'm not sure if it's Windows 3.1 or 3.11. Um, Basically, we can't define that because the difference between 3.1 and 3.11 is that 3.11 would allow you to become part of a domain. So network capability. Um, I would say that this is Windows 3.1. But you can see here that this was a breakthrough, right? You have the cursor, you have the mouse, you have icons in case you want to browse, visit web pages. You'd have the Netscape Navigator. And there is, I'm going to post a link to a documentary that shows the fight between Netscape and Microsoft, where they were fighting for their browsers. It was a browser competition. I'm going to post a link to that documentary if you want to write a document. So you can see here that you had so many different tools, and you just had to use your mouse to go wherever you wanted to go. And this is the similar solution, but this is a Mac computer. And now we can see how we evolved, right? So now we can look at what we have today. Nowadays we have we have automobiles with very high tech, very fancy digital devices, integrated digital devices. We have these uh, amazing smartphones, even refrigerators um, that you can basically, let's say, you can program that fridge to let you know when you are running out of milk, or you can use it to you can integrate it with Amazon, for example, in order to let the fridge itself purchase your purchase milk if you're running out of it. Then when you get home, there are some bottles of milk, some gallons of milk on your doorstep, because and you didn't do anything. Basically, your fridge did, and that uh, leads us to another topic that we're going to discuss in another class, which is Internet of Things. We have some other exotic interfaces, such as gesture controls, and those that like video games probably know this type of interface here, where the video game has an additional interface device that will um, read your movements. It's basically that device is connected to the video game and also filming um, a camera pointing out to the players where it's trying to read the movements based on three dimensional movements, and it's able to capture the movements that these people here are doing, and then it's translating those movements to the video game. Some other exotic interfaces we can see here: virtual reality. For those that have been to the iHub, at least probably know Oculus or whatever is the virtual reality device that you've seen. But basically, a virtual reality interface is an interface that will show you the, it will create a scenario, it will display that scenario, that scene in the screen that goes inside here in such a way that you feel like you are there. So it's 3D based to make you feel like you are there. And also you use these remote controls because this is what is going to sense the movements that you're making. So basically, the combination of that screen, that display that we're seeing, and these sensors that you have in your wrists or in your hands are going to translate your movements into the character that you're playing within that game. And we also have the augmented reality. One good example of that is Google Earth. So, for example, using Google Earth, you can visit several different places and you feel like you are there. Another one, very famous one, which is actually used for training purposes, for example, by pilots, um, commercial pilots, or in the military, which is a flight simulator. A flight simulator. So basically, as you can see here, the way it works is you pick a real world scene, you create virtual objects and add those virtual objects to that simulator or emulator, actually, and you visualize the digital as if it's real. So basically, in a flight simulator or flight emulator, that would be the more appropriate way of saying it. In a flight emulator, you are seeing a screen that will translate to you what would happen according to your decision, according to your movements. So it's very, very similar to uh, the real world situation. So, for example, in this type of scenario here, according to the way that you control, the airplane is going to respond. And it's very, very realistic. The the way that the airplane is going to respond here is very similar to the way that a real aircraft is going to respond. Same thing for automobiles. So, I'm sorry. So, this is our first introductory um, video where we were focused on the evolution of computers and also interfaces. Knowing, understanding what interfaces are is going to be very, very important for our next topics where we're going to discuss components. Obviously, understanding components is a critical part of the evolution of our course. I hope you enjoyed this lecture. Thank you. See you in the next one.